Hello friends, my name is AJ and welcome back to another in-depth review video for AP Computer Science. Today we're going to be going over Unit 9, which is Inheritance. The last two units, Unit 9, which is this one, and Unit 10, which is Recursion, which is going to be in the next one. These are a little bit more of conceptual topics, so I'm going to be explaining them a little bit more visually through this. There's less coding that's involved with them, but it's going to be more of thinking about how these things work. Without further ado, let's get started. All right, everyone, so the first thing is this unit is called Inheritance, and we have to obviously talk about what inheritance actually is. So inheritance is the idea of a class inheriting properties. So inheriting properties from another class. Now, what do I mean by this? I'm going to kind of walk through what I mean with an example. So let's say I have a class that represents vehicles. Okay, so I have a vehicle class right over here. And the vehicle class is going to specify, it's going to have certain fields and methods that kind of go with a vehicle, right? For example, the name of a vehicle, the make, the model of that vehicle. You may also have a method or an action, of course, which may be something like move forward. These are different fields and methods that go with the actual vehicle. But now let's think about another, like a more specific type of vehicle, such as, let's say, a car. Right? A car is a type of vehicle, right? There's an is-a relationship here. Is-a relationship, right? In the sense that a car is a vehicle. But I want you to kind of think about that it is a type of vehicle, but it's more of a specialized vehicle. In the sense that it is a specific type of vehicle, but there may be things that make a car a little bit more specialized, right, than a general term such as a vehicle, right? So for example, a car may have, something like a, number of passengers in a car, or it could be, the number of wheels on the car, the number of people who can be seated in a car, the actual the type of engine that's in a car. These are things that are maybe unique to a car, but that are different from other types of vehicles. But a car, still in a sense, is going to be a type. It's going to be a type of vehicle over here. But now let's think about another type of vehicle that we could work with. For example, a bus. A bus is another type of vehicle in addition to the car. So for example, what are some things that a bus may have that is unique to it, right? A bus may have, the color of the bus. If it's a yellow bus, if it's, say a white bus, you could talk about the type of bus, whether it's a school bus or an activity bus or a coach bus or a bus that takes people around in a city. These are all things that are unique to a bus that wouldn't necessarily translate over to a car or all different types of vehicles. However, for both the car and the bus, it still gets the properties that the vehicle had. For example, the car and the bus will still have the make, the model, the name of the vehicle. Those are all things that can still be, they can still be relevant to a car, right? But the things, or a bus, but the things that are relevant to just the car, or just the bus may not be relevant to the overall topic above. All right, so we talked about kind of that here, but let's add even another example of a vehicle into our mix. We have cars, we have buses, but we even have a train. A train is also technically a type of vehicle. It moves people around. But a train also has some unique things to it. For example, whether it's a steam engine or a diesel engine. It could have, Another thing that a train may have that other things wouldn't have is like a conductor, right? The name of the conductor of the train. These are things that the train may have that is different from the car and the bus or the other types of vehicles. So again, what I'm trying to kind of point to here is that you have this almost like a hierarchy that is being created here, right? A hierarchy, where you have a general type of something, like a vehicle here. And it has some basic properties, such as the name, make, and model, which are applicable to everything else below it, right? But you also have cars, you have buses, you have trains, and these are all types of vehicles that may have more specialized, right? They're specialized vehicles. They may have additional information that is specific to only it. Right? So basically what's happening here is that the car, the bus, and the train, they will get all of the properties from vehicle, right? So they'll get all of the fields, all of the descriptors, all of the methods, right, which are the actions. It gets all of those things from that overall, the overall vehicle, while at the same time it can add to it for each specific case. Right, so if a vehicle has name, make, and model, the car will have make, model, name, and maybe even something additional, right? Or train, it may have name, make, and model, but maybe you want to add the name of the conductor in there. So those are specialized things where it takes everything from vehicle, but then it adds on to it. In fact, we can go even further in this hierarchy, and I'm going to for this example, right? We can go further maybe into train. You can have something like a steam engine train, and a diesel engine train. These are two specific, these are even more specialized, right? So instead of being specialized vehicles now, these are specialized trains. And again, what I want to point to is that the steam engine train and the diesel engine train, they will have all of the same properties because this, right, what we're essentially saying is that the steam train and the diesel engine train, they're inheriting some innate basic characteristics of a train, but then you can add on to that so that they become more specialized for their specific purpose, right? For example, a diesel train may have a new field called oil level, right? The oil for the engine, compared to a steam engine train, which may have a different type of field related to the type of engine that it has. So that's kind of what we're going with here. Now, I want to talk about what we name this type of things, because we have a hierarchy that is created here. So a hierarchy is created. But one thing that I want to mention specifically is, what do we kind of call each level of this hierarchy? Well, it's going to actually be relative. So the first thing is that you usually have something called a superclass. The superclass. And the superclass will give certain things below it to its subclass. So everything below it in the hierarchy is considered its subclass. But now I want to go even further now. Let's look at train, right? Because vehicle is a superclass to train, and train is a subclass of vehicle. But now we look at diesel engine train, for example. And diesel engine train, right? Diesel engine train over here is technically a subclass of train. And train is the superclass of diesel engine, right? The diesel engine train. So really what you have is you have the fact that train is a subclass of vehicle. But train can also be a superclass of something else. In this case, it's a superclass of a steam engine train and diesel engine train. And so when you think about it, you always have a superclass above and a subclass below. So you can have, no matter how many times you add to this hierarchy, even if I add something below diesel engine train will then be a superclass of whatever's below it, but it is also a subclass. It is a subclass of whatever is above it. Sorry, I think I bumped my microphone there. So what we're talking about is we have superclasses and subclasses. And so when I talk about the example of how trains can maybe inherit certain properties, right? It can inherit the methods, it can inherit the fields of of the vehicle. What we're really saying is that subclasses themselves will inherit these properties from its superclass. So you have a superclass to subclass type of relationship here. It creates, again, a hierarchy. That's the main thing that you want to realize about this. You can have a hierarchy, and many times, many things are hierarchies. There's so many hierarchies built in with classes, and there's so many things that you could do with them, in the sense that you can have a superclass and then subclasses. Now, I want to go a little bit more specifically, maybe into an example, so you can see how things are actually inherited, and how you maybe will even edit the things that are inherited, and how that will affect everything down the chain that we go along. So here I have an example where I've written the vehicle class, I have a blank for train class, and then I have a blank for the diesel engine train class. So this is, again, following this general pattern that I have up here, where I went vehicle, train, and then diesel engine train. That is the specific hierarchy arm, so to speak, that I'm following here. So let's say I have the class of vehicle, and then I make the train a subclass of vehicle. So in this case, right, the train, or rather I can say that the vehicle is the superclass of the train. So being that the vehicle is the is the superclass of the train, there are certain things there that it can inherit, right? Or that the train can inherit from the vehicle class, being the subclass, right? Because the subclass inherits from the vehicle class, as we said up here, over here. Superclasses can kind of give its properties to its subclass. So what happens is you actually begin to inherit all of these things. You inherit, right, all of the fields and all of the methods, just like this. So this, I'm just going to move this over a little bit. So I have an inheritance relationship of name, make, and model. Now, one thing I do want to make very clear, though, is that constructors are not inherited. So up here, I'm writing, constructors are not inherited. So what happens here is instead, because obviously constructors can't be inherited, because the constructor's name, the name of the constructor, has to be the name of the actual class. I can't use a constructor named vehicle for a class named train. So really the constructor here will change. The constructor will change from vehicle to train. And this will be something that we write. So in fact, I'll change the color of this to specify that this is something that is innate to the train class. But again, I'm inheriting, right? I'm inheriting the name, make, model fields. These are directly coming from the vehicle class. I don't even need to specify these. Right? I don't even need to rewrite those fields in the train class because they're already inherited from the vehicle class. Now, we can add on to this. So for example, let's say I want to add another field on the bottom. And again, I'm kind of, this isn't actual code, obviously. What I'm doing is this is more of a pseudo thing where F's represent fields, C represent constructor, M equals method, and then here you can see I just write the typing of my fields next to them so that you know what I'm talking about. So let's say, in the example that I said above, I want to add another field or descriptor to the train class. And then the one I can add is the name of the conductor, right? The name of the conductor, which in this case will be a string. The name of the conductor. That is innate to the train class because I added it in the train class. It's not inherited from the vehicle class. And also, one thing I do want to make very clear, the conductor class does not, right, carry over to the vehicle class because the train class is a subclass of the vehicle, right? So in this case, only the train class inherits from vehicle. Vehicle does not inherit from train. So in this case, again, I'm inheriting the name, make, and model fields and the move forward method, but then I have the constructor, which is unique to the train class, and now this new conductor field, which is unique to the train class. Now, one thing I do want to mention is what if the method over here, I have move forward for vehicle, move forward for train. But what if the actual methodology that the train moves forward? What if it's different? Right? Like, what if I want to modify how a train moves forward from the vehicle, what the method was for vehicle, right? In the sense that I have my move forward method, I keep the header the same, but the code inside of the body I want to change. Well, you can do that, and actually doing this is called, so I'm going to star this. This is called overriding a method. So overriding a method refers to that in the subclass, you change the body of a method that is inherited from the superclass. So in this case, again, move forward becomes specific to the train class because I'm taking it from vehicle, but then I am overriding it. I'm overriding what was inherited to be something new. And that is what is over here for the move forward method. Okay, so now I've talked about actually inheriting. So I'm inheriting from the vehicle class. The train class is inheriting from the vehicle class. Remember, you can inherit methods, fields, and not constructors. So again, the constructor is unique. I then add another unique field here called conductor, which is specific for the train class. And then I talked about overriding methods. I overrode the move forward method from vehicle. But now let's go to the last item in the chain. So over here, right, we say that vehicle is a superclass of train. Well, if you go back to the hierarchy, train is a superclass of diesel engine train, right? The diesel engine train is below train. So the train right over here is a superclass of my diesel engine train. So then what happens here? Well, let's say I automatically inherit everything over here. I automatically inherit these right over here. I automatically inherit these fields, and it looks like I may have done this a little bit too big, so I'm just going to make my arrows slightly bigger over here, like that, or smaller rather. So you can see that now I've inherited my fields. Now remember, now we move down to the constructor. Remember, constructors are not inherited, right? So when I go over here and I add my constructor, then this constructor is going to be specific to diesel engine train over here. So I can simply go and call this constructor like diesel engine train. Right? That's the constructor. Remember, constructors are not inherited. So in this case, I'm going to highlight this to show that there are no arrows, that they're unique for every single individual one. They are not inherited. And then we go over to methods. And remember, we inherit everything. So we inherit methods and fields. So we will actually inherit, or the diesel engine train will actually inherit both of these as well, because these are methods and fields. I'm going to make this a little bit smaller over here and over here, just so that it's easier to fit them. Okay. So you can see that move forward is inherited and constructor is also inherited. But now I would like to think about this over here, because I actually overrode. Let me choose a yellow over here. I actually overrode my move forward method right here. That is overwritten I overwrote the move forward method from vehicle. So which one am I actually going to inherit, right? What is my subclass diesel engine train? Which move forward is it going to inherit? Is it going to inherit the move forward from a train, or is it going to inherit the one from vehicle? Well, this again goes back to the definitions, that the subclass will always inherit from its superclass. In this case, the superclass of my diesel engine train is going to be specifically, looks like there's a little bit of a glitch up there. We're just going to ignore that. It is the actual superclass of diesel engine train is train. So therefore, we're actually going to inherit the overridden method. We're going to inherit what was from train, not from vehicle, right? Whatever is closest in the hierarchy or whatever's directly above is what it's going to inherit. So if I modify my method in this class right over here, I'm going to inherit everything afterward in the chain is going to inherit the modified method. And then of course fields right over here are inherited. And then the last thing I can say is I can add a field here. Let's say I want to add a field for oil level, right? And I can say that this is a double. So this field over here, oil level, is simply, again, I'm adding, just like I added conductor over here, I can add my own specialized field for diesel engine trade, which makes it unique from train and more specialized. So this is a very good diagram and this is the main reason I especially wanted to show this diagram, is because it shows you the relationships and how things are inherited and carried through from superclass to subclass and then to subclass, etc. And now the last thing I want to do is I actually want to talk about, because we talk about this conceptually now. We talked about, the idea of inheritance and how a subclass inherits from a superclass and how it goes down the chain. But now how do we write this in code? Right? How do we specify, for example, that a train class over here is actually the subclass of vehicle right over here? How do we inherit, how do we actually override methods? Like how I showed over here, where we overrode and modify the move forward field. So let's take a look at this example. So I actually wrote the code below for each of these three classes, and we're going to kind of analyze what it looks like over here. We're going to analyze it. So the first thing down here is that I have my vehicle field. So again, this was kind of my information for my vehicle field. I have a string field for the name, make, and model. I have the vehicle constructor, which is over here, and then I have my move forward method. Now, just again, for the simplicity of it, I put a comment that said do something, right? There's some sort of process that happens there. I omitted it from this example simply so that, it's kind of like this, implementation not shown. It's just extraneous. I just wanted to show you the structure. So you can see that is what the vehicle class looks like. That there's actually nothing that is uniquely different about the vehicle class. But now let's take a look at the train class, which is below it. And now this is where you see our new keyword for Java, and that is the extends keyword. So what you do is in the header of your class, if you want your class to be a subclass of some other class, you use the extends keyword. You say extends, and then the class that you want, for example, the train class to be a subclass of. This is going to be your superclass. So you say extends, and then you put your superclass over here. So now what this allows me to do is this actually allows me to inherit all of the things up here. And you can see that I don't rewrite the fields, name, make, and model. They are automatically inherited. Just because you can't see them here, right, doesn't mean that they're not there. So the only thing I have to write is conductor, which is my new field. Because the other three fields, as I showed up here in this diagram, they are directly inherited from the superclass. So I don't even have to write them again. Now, also, one thing I do want to note to, is that I wrote all my fields here in public. Remember, usually I talk about writing them in private. The reason I wrote them in public, in this case, is so that I can access them. Because, remember, private restricts fields so that they are specifically contained to that class and that you can't use them outside of the class. But in this case, because I'm inheriting stuff, I will be using stuff from other classes. Therefore, I left everything as public just to be safe that everything works. Okay, it's just a simple example. So you can see here that, again, my field constructor is the only thing I write, or the field conductor is the only thing I write. And then over here, I implement my new constructor because, again, I need to include an actual constructor. Constructors are not inherited, so I need to write a new constructor. And then the last thing is, how do you actually override override a method? And to override a method, all you do is you write the exact header for the method again, and then you provide a new body for the code. So even though, over here, my method is inherited, I just have to write it again, right? All I have to do is write it again, I'm going to use the same color that I did above, right over here. I just write it again, and then this entire method overrides. So this is the overriding the method. So now the code inside of move forward that I specify over here will be the overwritten method. Okay, now the last thing I want to talk about is my diesel engine train class over here. So you can see that again, I use the extends train. So now I'm basically saying that I want the superclass of diesel engine train to be train, right? Or again, you can flip it around that I want train to be the superclass of diesel engine train, right? You can say subclass, superclass. It goes both ways here. Now, of course, the order is important, right? Diesel engine train is the subclass of train, and train is the superclass of diesel engine train. So then again, in this case, the only field that I write again is my oil level field. The oil level, I again don't need to rewrite. I inherit the field conductor, the make, name, and model, because those were all from superclasses. So I automatically inherit all of those. I don't need to rewrite them again. And then the last thing I need to include is my constructor, because of course constructors are not inherited. So basically you can see that what I've done is, even though my class here is so small, I only have one field in a constructor, right, it seems. If I go back to my diagram, you really see that I'm actually getting all of these things in that field in the way it's written. I'm getting name, make, and model from the superclass. I'm getting move forward from the superclass. I'm even getting conductor from the superclass as well. All right, so that pretty much wraps up. There's only one more thing I want to talk about, and that is going to be super. So what does super actually mean? Well, super accesses the superclass's constructor. It accesses the superclass's constructor. Now, why would you want this? Well, for example, let's say I have I go up here in let's just say my train class, and I have a constructor over here, right? That's train. I still need, because remember, the job of a constructor is to initialize the fields. So I still need to initialize the fields that are inherited up here. So by calling super inside of my constructor, right, what I can do is I can basically take care of it. I can use the code for the constructor, up in the actual superclass, and then I can simply add on the remaining code to take care of my new fields. So that's why super is very, very useful. And then of course you put these same parameters in your super call that you would with the constructor call of the superclass. The last thing I want to talk about, which is also something that I think is important to note when we talk about superclasses and subclasses, is let's say I have an array list. This is from Unit 7. An array list of vehicles. And then I also have an array list of trains. Right? If you think about it, think about kind of the scope and how things are more specific. Right? We say that squares are a type of rectangle, but rectangles are not a type of square. It kind of goes with the superclass subclass type thing if you apply it. Right? The superclass would be rectangle and the subclass would be squares. So squares are technically a type of rectangle. So inside of my list of vehicles, I can technically put a train object in here because a train is technically a type of vehicle. Yeah, it's a more specific vehicle, but it is a type of vehicle, and I can add train to a list of vehicles. But this doesn't go both ways, right? This doesn't go both ways. So here, if I have a list of trains, I cannot add a vehicle to my list of trains because, again, vehicle is too general, right? And trains is too specific. So remember the order here. You cannot put in a list, you cannot put a superclass in a list of objects that are supposed to be the subclass. And the best way, again, to think about this is think about the rectangle square type thing. If I had a list of squares, would I add a rectangle to a list of squares? No, because a rectangle is not a type of square, right? But if I had a list of rectangles, I could add a square to it because a square is a type of rectangle. All right, so that is going to be it for the part 1 of this particular unit. This one's longer, and of course, it's one of the more conceptual, more difficult kind of for people to understand, because it's often, there's a lot of things you don't see. It's more conceptual rather than applied here. So again, in this video, we talked about the concept of inheritance. We talked about super and subclasses. We talked about overriding methods. We talked about using the extends keyword, so actually, applying this concept in code. And then we talked about super, and then the entire thing with lists. Now, if you have any questions on any of these things, as these things again are a little bit more, they're a little bit more difficult to understand. So if you have any questions, definitely leave them in the comment section below. If you like the video, feel free to like and subscribe for more content. And as always, thanks for watching. The practice test in the video, or the practice test in the video description, I will be going the answers to in the second part of this video. So definitely check out the description, try out the practice test, and then I will be going over the answers in part 2. See you then.